Hello everyone, welcome to my channel Middleware Technologies. Today I would like to share my experience on how we can prepare for the Certified Kubernetes Security Specialist examination. So this is a very popular certification that people try to achieve in order to show their expertise in the security field for the Kubernetes. So I'd like to share what documentation, what books and uh, courses that I have been doing to achieve the certification. So before that, this is the certification that I have received on 27th. Like I have taken my exam on 27th and I received my results on 28th. So this is the certification that I have received from the CNCF. Let me now go through the the resources that I have been following for this certification. So first of all, let us talk about the books. So there are two books that I have been referring for this Kubernetes security hardening, and the first one is Learn Kubernetes Security by these people. Okay, so this is a good book, but basically pretty old on the tools that they have been using in the book. But the concepts that have been like the concept that concepts that have been explained on in this book are really going to help you understand the internals of the Kubernetes cluster. So it is a must, if you have this book, or you can download it online and try to understand or go through this book at least once for the certification. The second book that I am referring is Hacking and Securing the Docker Containers by Srinivas Rao Kotupalli. This is an optional read if you want to go through. This is basically to gain an understanding about the Docker containers and the images and how they are built, and what type of best practices that you can follow in order to containerize your application. So these are the two books that I would like to refer for the Kubernetes security hardening. Now let us go to the course that I have been following. So I have been following the CKS course by Kim, which is now available on YouTube for free. So this one is very comprehensive, and it is aligned like it is structured as per the CKS examination curriculum. So this is a must. I would prefer you guys go through this course and complete the tests that are given for each scenarios through killer shell, and you also get a simulator from the killer shell wherein you will have a simulator like exam, wherein you will be able you will be asked to complete a set of questions in a defined period. So you will be able to you will get comfortable with basically how you can actually take the exam in the real simulator. Okay. Now let us go through the documentation that I have been referring for this exam. So the first thing is Kubernetes documentation. So Kubernetes documentation is the one thing that if you are going through is really a good thing, because you will get to know different things that have changed in the new version of the cluster. So currently, if you search for Kubernetes documentation, and go through the Kubernetes documentation, and you can try to navigate to installing kubeadm. So you can see the instructions guide, the documentation that currently you are referring to is for the version 1.29. so this is the latest version that is available from Kubernetes, and this is the version that you are going to basically work on the examination also. So try to be comfortable with this version, try to go through the documentation as much as possible. Specifically, like if I would say, like you can go through the concepts and the security section, wherein it will explain you about the different security aspects that you can configure or harden in the Kubernetes cluster. And you can also try to go through the tasks and try to do all the relevant tasks related to the security, the Kubernetes security hardening stuff. So this is basically high level, like you can go through the documentation for the Kubernetes. There are a few things that have been like deprecating or deprecated in the Kubernetes in the recent version. Like the pod security policy is deprecated and it is being replaced with the pod security standards. And the other thing that I have noticed is the Ingress feature that has been frozen and is getting replaced, getting added to the gateway API. So these are the few things that you will get to know if you are reading the documentation. Otherwise, like if you are just going through the course material, like you will not get to know about the different things or the different new features that have been getting added and the older features that have been getting deprecated in the new version of the Kubernetes cluster. So this is I would prefer like you guys to go through the Kubernetes documentation at least once and give it a glance, like what are the features that have been added or removed in the new version. So you can go through the course and parallelly go through the documentation as and when a new topic gets covered in the course material. So that's how like you can follow the documentation also. Now let us go through this the important topics that are relevant to the Kubernetes security certification. So the first one that we are going to look at is service accounts. Okay, so service accounts, so let me search for service accounts in the documentation, and the first link that you get is the configuring the service account for pods. So basically, like service accounts are like system accounts in Linux. So in Kubernetes cluster, like we have pods like which are running our processes, and these processes we can run it using service accounts. So service accounts are the ones that are used to run that we can use in order to run our processes in the containers, and these accounts can be given the required level of privileges like or the permissions in order to communicate with the Kubernetes API cluster. Like they can use the service accounts in order to request for any resource or request for any communicate with other pods in the cluster. So this is something about the service accounts, and you should be comfortable enough to modify your pods in such a way that they are able to use the customized service accounts, or you should be able comfortable in looking at where the service accounts are mounted within the pod. And also, like service accounts can be used to basically pull images for the pods. So what I mean to say is like service accounts are basically system accounts which are used by pods, and these system accounts basically are a set of credentials that you can say. So these credentials can be used to further user to pull images from the registry. So we can create a service account that has access to pull the images from the customized registry. So that's how, like, you should be able to comfortable enough to use the service accounts within the pods. Now let us go to the documentation again. The next documentation that I would like you to refer is the secrets. Okay, so now if you go and search for secrets in the Kubernetes documentation, and you can just open the first link. Okay, so secrets are basically the objects that are used to encrypt your confidential data. So this confidential data can be anything like passwords or tokens, API tokens, or the certificate keys. Okay, so these confidential data can be encrypted using the secrets, and there are various different types of secrets that you can use in order to encrypt different types of data. And this is very important topic for the Kubernetes certification. So you should be comfortable enough to like basically take a string or take a file and encrypt it using the Kubernetes secret object, and you should be able to use those secrets in your pods. Basically, you should be able to mount those secrets as volumes in your pods, or you should be comfortable enough to refer your secrets as environment variables in your pods. So you should go through this documentation. And also, the one more important thing about secrets is you should be able to store your secrets in an encrypted fashion in your cluster. So basically, the cluster configuration is all stored in the etcd persistent data store, and this data store stores your secrets which you are creating in a plain text format. So you should be knowing about how you can capture your secrets from the etcd database using in plain text when there is no encryption available at rest. This is very important, like encryption at rest is required in your cluster. So you should be able to encrypt your data in the etcd cluster at rest, and for that you can go through this documentation, enable encryption at rest. Now like coming to the secrets, so as I said, like there are different types of secrets that you can create. So these are the types of secrets that you can see: opaque secrets, service account token secrets, docker config secrets. So TLS secrets which can be used to encrypt your certificates, like the cert file and key files. So you should be able to you should be comfortable enough to create your secrets of different types of data. And like there are for coming to the exams, like you should be able to use these imperative commands in order to create your secrets, rather than trying to create this YAML definition file, because this is going to take you a lot more time than running this imperative commands. So you should be comfortable enough to work on creating your secrets using the imperative commands. So this is something about secrets. Now let us go into our documentation, and the third thing that I would like you to refer in the documentation is auditing. So let me search for auditing over here. And the first link is what you are going to refer for auditing. Auditing is basically like what is happening in the Kubernetes cluster, and from where it is happening, and who is triggering that event. So all these events can be captured in the Kubernetes cluster by enabling that auditing policy in the Kubernetes API server. Okay, so this is a basic audit policy that you can try to refer and try to understand, like what basically are the different levels of data that you can capture, and what are the different stages of stages a request goes through, and each like, so you can see like these are the levels of data that you can capture, and these are all the different stages through which the request goes through. So you should be able to comfortably edit the policy YAML definition file in order to capture only the relevant data of the event. So let's say, like, if you are capturing the data for secrets, so let me show you. So this is the secrets. Okay, so if you're capturing the events for secrets, you should be capturing only the level metadata, because metadata, it only shows you the information about the request metadata. If you are capturing the secrets at the request and response level, like, it is going to basically show you the request and response bodies of this secrets, which might expose your secrets in the logs that you are capturing for the auditing. So this is not a good idea. So this is how, like, you should be able to know, like, which type of configuration, which type of object or resource can be captured at what level. Okay, and you should be able to update your so let me update your Kubernetes API document, API configuration with the required audit policy file and the log path, wherein you will be able to like, capture the audit logs. So just go through this auditing documentation from Kubernetes, and try to understand, like, how you can enable the audit policy and how you can capture the logs for the audits is based on the audit policy file that you create. And yes, so that is all about auditing. Now let us go to the next topic, that is admission controllers. So let me search for admission controllers over here, and it will take you to the admission controller reference documentation page. So here, like, it refers to all the admission controllers that are available and how we can enable them. So basically, this is how you can enable the admission controller, and you should be able to understand what admission controller is all about. So let's say if you go to always admit, so this admission control allows all the pods into the cluster. So it is deprecated because its behavior is same as there is no admission controller at all. So by default, like, the Kubernetes cluster behaves like it always admits all the pods in the cluster, and the exactly opposite admission controller is always denied. All the requests are rejected when we enable this always deny, which is deprecated as there is no real meaning in this one. Okay, so these are something that keeps on changing with version to version. So you need to be comfortable like, enabling the admission controller and see, like, what exactly that admission controller does. So always pull image admission controller. So it is basically ensures that whenever you are creating a pod, it always pulls the image from your registry rather than pulling or using an image that has already been pulled from the cache. So these are some features that will help you in improving your security posture of the cluster. So just go through all the admission controllers that are available over here, and there are a few admission controllers that are important from the security perspective. So you will just get to know, like, while you go through the course documentation, you will get to know, like, what type of admission controllers you might need to enable, and you can get into the details of those admission controllers over here in this documentation. So that is all about the admission controllers. Now let us go to the RBAC authorization, and here you can just search for RBAC, that is role-based access control. So this is basically nothing but the concept related to the least privilege. uh, so basically, when we are creating a user, we uh, we assign that user to a particular role, and that role is assigned some set of permissions. So this role-based access control also works on the same concepts. So we create some set of roles, and these roles are nothing but a set of permissions to the resources, and we are going to bind these roles to a particular user or a particular group or a particular service account. So you need to be comfortable enough in order to work with creating your roles and role bindings, and how these roles or role bindings can be can be assigned to a particular user or a service account, and how these bindings affect a user's permission to users or the service accounts permission to the cluster. So what type of actions that he can carry out when a particular role binding is applied to a user. So you should be comfortable enough to work with the imperative commands over here. So just go through all these imperative commands in order to create the roles, create the cluster roles, role bindings, and cluster role bindings, and how these role and role bindings will help you to so let's say if I'll go through one of the role, so let's try to understand over here. So this is one role wherein we are creating a role for pods resources, which can be on which we can do get, watch, and list requests. So this is one type of permission that we are granting on the pods. But for whom we are going to grant this permission? So we are going to assign that role using the role binding. So basically in this role binding, we are going to assign this user that following particular role, so that this user gets the required level of access, that is he can do get, list, and watch on the pods for which is granted based on this role. So this is how you should be able to comfortably work on creating your roles, cluster roles, or role bindings and cluster role bindings. So this is something brief about the RBAC. Just go through this documentation and get an understanding about the RBAC authorization policies. Now let us go into the next topic, that is pod security admission. So if you can search for pod security admission, it will directly take you to that page. So pod security is basically so before going into the pod security admission, let us try to understand about pod security standards. So there are three levels, the three set of profiles: privileged, baseline, and restricted. So privileged is basically giving your pods all the privileges, are giving it's kind of a unrestricted policy that when applied to a pod, that pod gets all the accesses required, all the accesses, widest possible accesses that you can say to do their activity. And the second profile is baseline. So baseline is a kind of restricted policy wherein the pods are allowed to do only some set of activities. So they will not be able to do privileged activities, some set of privileged activities. And the third policy is basically restricted, wherein there are stringent security restrictions are applied to the pods when this policy is taken into effect. So how we are going to enforce basically this pod security standard. So that's where the pod security admission comes into picture. So here, like, we are going to update our pods with these annotations, wherein we enforce the level of restriction basically by using these kinds of modes. So there are three types of modes: enforce, audit, or warn. So we how we want to apply the restriction. So let's say if we want to apply the baseline restriction, or the policy restriction, or the privilege restriction. So how we are going to apply those restrictions using these modes. So enforce is basically is going to block your pod when restrictive or baseline policy is applied, and your pod is doing some kind of activity which is not allowed as per that policy. So enforce when you are using when you are going to update your pod and apply that restriction using the enforce mode, that is going to block your pod when it is trying to do some kind of activity which is restricted. And the other two modes, that is audit and warn, is basically audit is basically audit mode is going to like log an audit event based on the restriction levels that you have applied, and what that pod is trying to do based on what that pod is trying to do. Okay, so this is going to be auditing all these events in your audit log. And the third one is the warn mode, wherein whenever you are trying to create a pod with some kind of behavior that is restricted, it is going to warn you on that command line itself, like that pod is trying to do some kind of restrictive behavior which is basically blocked, which is basically restricted based on the policy that you are using. So this is how the pod security standards and the pod security admission works, and you should be able to comfortable enough to enforce this pod security standards at the namespace level, and you should be able to enforce this pod security standards by enabling it at the admission controller level. So go through this documentation and get some hands-on to work with the pod security standards. Now let us go to the next documentation, that is network policies. Network policies, so let me open this documentation. Network policies is all about the isolations that we apply to the pods. So what type of so this network policy isolation works at the IP address and the port level. So what pods can communicate, so it basically provides a set of rules that we apply it to our pods to ensure that pods are able to communicate or with only a set of pods which are with some set of IP addresses, or a set of pods in a particular namespace, or so this is basically restricting the pods egress or ingress traffic. So you can isolate your pods to only allow traffic from some set of endpoints, and you can block your pods to allow traffic, the egress outgoing traffic, to only a set of endpoints. So this is how the network policies behave, and you should be comfortable enough to create your network policies and apply those network policies to a set of pods with a set of labels, and update your ingress and egress policies in such a way that they are allowed to allowed for a particular set of egress traffic, and allowed for a particular allowed for a particular set of ingress traffic. That is, they can take traffic from a particular ingress endpoints only. Okay, so this is the documentation that you are required to go through for network policies and be comfortable with applying those network policies. Now let us go to the next topic, that is Ingress. Ingress is another topic that is basically provides access to your services in the cluster using the external endpoint. So basically, like you create Ingress, which is basically an Nginx server, you can say, which provides a proxy to your services that are running in the cluster. Okay, so you should be able to create your Ingress objects to modify your Nginx server or Nginx controller and see like how that Ingress can be used to get access to your services in the backend, and how you can secure your Ingress using the TLS certificates. Okay, so you should be able to comfortable enough to modify your Ingress object to secure it, so that the communication that happens between between the end user and the Ingress object is secured. Now let us go into our next topic, that is runtime class. Let me search for runtime class. So what is runtime class? So basically, like as we know, whenever you're trying to set up a cluster, Kubernetes cluster, the first thing that we need to understand is what type of runtime environment that we want to use. So there is containerd, there is Docker runtime, there is CRIO runtime. So these are different types of runtimes that you can use. So these the pods that we create are using this runtime implementations, or the runtime environments, you can say, in order to launch their containers. Okay, so in order for to ensure that your pods are using a customized runtime environment or a secure runtime environment for a particular set of workloads, you should be able to you should be comfortable enough to create a customized runtime class in order to apply that runtime class to a specific set of pods in your environment. So this is something very important for your examination, so please go through this documentation and try to be comfortable to create your customized runtime classes, and try to identify what are the different types of handlers for different types of runtime environments that we can use in the Kubernetes cluster, and how we can apply that that runtime class to a particular pod. Okay, so so how we can apply that runtime class to a particular pod, so that particular pod uses that specific runtime class in order to launch their containers. So this is one topic that should be you should go through this documentation to get a better understanding. Now let us go to the next topic, that is upgrading the cluster. So this is very important in terms of any software, we can say, like any software that we are going to use, we need to ensure that we are updating our software with the latest version to make sure that is up to date with the security fixes. So the same thing applies with the Kubernetes cluster also. We should be comfortable enough to upgrade our cluster with the latest version that is available, because the latest version of the Kubernetes clusters always try to fix the security vulnerabilities that they have identified, and the latest versions also help you to get the latest features or enhancements in the cluster. So you should be able to comfortably update the Kubernetes cluster, both the control plane nodes and the worker nodes. So you can just go through this documentation and see like how the worker nodes like how the control plane nodes are getting are upgraded, and what commands are used to upgrade that control plane nodes, and what commands are used to upgrade your worker nodes. So this is what like you can go through for upgrading your cluster. The next thing is securing the components. So uh, we can search for API server over here, and it will take you directly to the Kube API server reference documentation page. Okay, so if you navigate through the left uh, navigation bar, like you will see like the different components that are that we use in our Kubernetes cluster. So you know about Kubernetes API server, controller manager, proxy server, scheduler, so kubelet. So these are all the different components that we use in our Kubernetes, either the control plane node or the worker node. Okay, you should be you can go through all this Kube API, all these options that we can pass in order to the Kubernetes API server, and try to understand what are the security related options that we can enable in the Kube API server to ensure that our Kubernetes API server is highly secured or hardened. Okay, so these documentations are relevant pages that you should go through. Like there are settings related to ciphers and protocols, and the Kubernetes API server is one of the documentation, but you can refer to all this kubelet, the kube controller manager, and the other documentation where it shows what are the different options that you can pass to your the manifest or the component in order to ensure that they are secured. So just go through this roughly, like understand what different options do, and what are relevant to the security features, what are relevant to ensure that your component is secured. Now let us go to the next topic, that is security context. Security context, so it's basically related to the pod security standards. So security context are the configuration that we enable at the pod or container level. So we can modify or update our pod in such a way that we can ensure that the pod is running as a privileged pod, or we can ensure that the pod has access to the root file system, and we can enable the Linux capabilities in our pod. So these are all the things that we can apply to our pod to make it more what do we say, that more flexible, we can say. But at the same time, if you want to restrict our pods to not do some kind of restrict our pods to not do some kind of activities that it is not supposed to do, then you can enable the relevant security contexts for that pods also. So let's say like you can enable this configuration in order to run your processes as a particular user rather than root user. You can enable this configuration for security context to allow to restrict the privileged escalation that can be granted to the pods. So there are different settings that you can configure for these pods. So you can just go through all this documentation, like enabling the security context for containers, how we can enable the capabilities, how we can enable the SLNX context, SLNX labels to the containers. So this will help you understand like how we can configure our pod and ensure that it is more secure. Now let us go to the next topic, that is CKS benchmarking. So this is one topic wherein you will need to scan your Kubernetes cluster in order to make sure that is security hardened. So for this, the thing is, like, you need to go through the CKS benchmarking Kubernetes. Okay, so you can go to this portal and try to download the latest CKS benchmark for Kubernetes, and it will show you all the relevant security settings that you can apply in order to secure your Kubernetes cluster. So this is the documentation that I have downloaded. This is the latest documentation that you can get which has been updated as of this date. So here you can see, like, these are all the recommendations that you get for your control plane components, for API servers, controller managers, etcd schedulers. So you can just have a glance at all these configurations that you can carry out to your the components that you are running in the running in your cluster, and be comfortable, like, which settings when applied will mitigate your Kubernetes issue. Like, basically, let's say if you have a relaxed permissions on a set of configurations file, like, you can just go through this documentation and see, like, what type of permissions we are supposed to grant to that particular configuration file in order to make sure that is more secure. So though that kind of settings that we can apply it to the components, the API servers as an options, or the permissions that we can apply to the configuration file, that you can go through in this documentation. Just go through and have be comfortable with what options are applied at what levels, like basically at which components, so that you are not like surprised on, like, how we can apply this option for this particular component. Okay, now let me go to my documentation again. Now let us go to our next topic, that is Docker files and Kubernetes YAML definition files. So these two files are basically you should be able to harden, or basically follow the best practices to ensure that your Docker image that you are creating is having a small footprint, and ensure that your Docker image is following all the best security practices for building your image. And the same applies to the Kubernetes YAML definition file for your workloads. You should be comfortable enough to modify your Kubernetes YAML definition files with the relevant security context to ensure that they are security hardened. So you can just go through the documentation for the overview of best practices for writing Docker files, which is available in the Docker documentation, and the Kubernetes YAML for the security context related to the Kubernetes YAML definition file hardening. Now let us go to the next thing, that is Trivy. So Trivy is basically an image scanner which will help you identify what all vulnerabilities are available in your in your image that you are using in your workloads. Okay, so you should be comfortable enough to use Trivy in order to identify what type of CVEs are impacting your image, and what type of severity level CVEs are like basically impacting your images. So we run pods with us in our Kubernetes cluster. Okay, and these pods are launching the containers based on a set of image, and you should be able to grab what type of image these pods are using, and use that image in order to scan it using Trivy, and try to identify what type of CVEs or what type of severity level CVEs are present in that in that image and try to avoid using those images for your pods. So that is what Trivy is all about. Now let us go to the next thing, that is Falco. So Falco is basically provides a real-time threat detection for cloud containers and Kubernetes workloads. So what does it mean? So Falco, when it is installed and enabled in your cluster, it runs a set of rules which filters your requests and tries to identify what your cluster is trying to do in through the auditing logs. So Falco rules can be applied, and the log formats can be modified in such a way that you get to know the information relevant to your containers and what type of users are launching those containers and what type of behavior that container is doing within the cluster. So whether it is trying to install some packages within the container, or it is trying to launch some kind of processes or irrelevant processes which are not relevant to your Kubernetes behavior. So those kind of activities can be captured using Falco when enabled using the Falco rules, and you should be comfortable enough to install the Falco and try to modify the Falco rules, the default rules that are available for you, and you should be able to capture the logs relevant to the pods that are doing a specific kind of behavior as per the rules. So that is all about Falco. Now let us go to this the other topic, that is etcd. So as I said, etcd is basically a persistent storage that is used in the cluster in order to store your data related to the Kubernetes cluster. So if you go to the etcd documentation, you can just navigate to the operations configuration options. So this is where you will get to know about the security related options that you can apply in order to ensure that your Kubernetes etcd server is secure. So just go through all these options and try to be comfortable in applying these options to your etcd manifest or the etcd server YAML definition file, you can say, and ensure that your etcd server is secure. And there are some additional documentations that you can follow, which I've shared in this the blog. I'll be sharing this blog reference in my video description, so you can just go through this additional documentation. And the Linux candidate handbook is a must that you should go through before taking your exam, so that you understand what type of environment you should be having before taking your exam, and what is allowed and what is not allowed for the exam, relevant to what type of documentation that you can refer in the exam and how you can refer the exam, and what type of exam simulator that you get to see. So those type of information that you have in this handbook that you just need to go through. And last but not the least, the important point that I would like to highlight is basically whenever you are trying to update any configuration file, or trying to create any pod, or trying to create any rules, or anything that you are trying to do within your cluster, try to validate the results. That is very important. So let's say if you are applying some configuration changes to the Kubernetes API server or controller manager or the scheduler, try to ensure that your the components like the API server, the etcd server, scheduler, or the control plane components are coming up within
the stipulated time. So it should not take more than a minute for your the conference to come up after you do some necessary security hardening changes. Okay, if something is not coming up even after 1 minute, then there is definitely something wrong with your configuration, and you should be comfortable enough to go through the logs of those Kubernetes components, and you should be comfortable navigating to that location and try to analyze those logs and try to see like what went wrong with your configuration. Okay, so that is more important, and try to make sure that whatever changes you are doing it right in the first step itself, because there won't be much time left for you to basically go and try to do that configuration again, because you'll get approximately like 15 to 17 questions in the exam, and you have approximately 120 minutes in order to complete your exam. So given like if you're giving each question 5 minutes, that will sufficient that will approximately cover the whole 1 to 2 minutes for your exam. Okay, so there won't be much time left for you until unless you are very fast enough to do your activities or do your questionnaires, and you have very good grasp on the Kubernetes components, like Kubernetes imperative commands, as I say. Okay, so this is all I wanted to share you about the Kubernetes certified Kubernetes security specialist examination, and how what are the different security related documentation that you can go through, and how you can take the exam. So I hope you enjoyed watching this video, and you get to see some important information for this exam. So thank you all, thanks for watching this video, and you guys have a great day.